Hello, scholarly gamers, and welcome to Proof of Console, the show where we look at something from video games from a mathematical or scientific standpoint to see how plausible it really is. I know I've already covered one game by Rare in the past, but how can I possibly pass up a chance to talk about Viva Pinata? It's a sandbox game like none I've ever seen before. Your objective is to gather piñatas of all shapes and sizes to your garden, where they reach maximum candiosity and get fired out of a huge cannon in Piñata Central to be at parties all over the world. The music is pleasant, the colors are vivid, and the characters are charming. But let's think about these supposed mechanics for a moment. Is it actually possible for the Cannonata to reach any point in the entire world? And if not, where would the most advantageous location for Piñata Island be located to reach the most parties? That's what we'll be exploring on today's episode. The Viva Pinata series naturally doesn't have any specifics when it comes to the Cannonata or how it functions. All we do know is that the cannon is a multi-barreled monstrosity in the center of the island. When there is need for a piñata from a horstachio to a fudge hog to a fizzly bear, Piñata Central will ask for one or more. Then you just pack the paper pal away and it's blasted off to whatever party it's needed for. Now the lore tells us the Cannonata fires piñatas to anywhere in the world, but really the Piñata is a game that originates in Mexico and only exists there and in the US. Though similar games can be found in Denmark, Spain, Italy, Japan, India, the Philippines, and Vietnam, they're not quite the same as seen in the video games. To make it simpler, we'll assume all over the world really just means all over North America. So if we want to see if this Cannonata thing really works how it says it works, we'll need a real-life example to compare it to. The best we have is a concept developed in the late 1800s but never really saw its full potential: the space gun. In 1865, Jules Verne published a hard sci-fi book called From Earth to the Moon about a group of men wishing to use their expertise in cannons in post-Civil War era America to launch a projectile all the way to the moon by building an absolutely enormous gun called the Columbiad. This idea came long before rockets and jet propulsion systems even existed, so firing a big freaking gun seemed like the best option. Indeed, just as the space race was heating up between the US and Soviet Union, the American and Canadian governments came together to devise a space gun based on the specs laid out in Jules Verne's book. Between 1961 and 1967, Project HARP, or High Altitude Research Project, created a huge gun to be fired in Barbados. This project was really just a proof of concept to see if we could really fire a projectile into space based on some 100-year-old math. In the end, the cannon ended up being 130 feet long with a 16-inch wide barrel, repurposed from the cannon on a Navy battleship. A number of tests were performed, but the best result caused a 400-pound projectile to be fired 113 miles in the air, past the traditional edge of space. It traveled super fast at 2,134 meters per second. In the early 90s, however, there was talk of a super high-altitude research project that would have been 154 feet long and could fire projectiles as fast as 7 kilometers a second, but it became too expensive and was cancelled. Therefore, Project HARP was and continues to be the most powerful gun ever fired. That's all well and good, but we need to see if that much firepower can actually reach all of North America. Since Project HARP was meant for firing things straight up, we'll have to do some math to calculate how far the cannon can shoot at an angle, specifically a 45-degree angle, the one that can get the most distance. It's actually pretty complicated to figure out how far a gun can fire using trajectory, but thankfully we already have all the info we need. We know the angle and the speed of Project HARP's best test, as well as the acceleration of falling objects, negative 9.8 meters per second. Then all we need to do is plug in those numbers to these 5 equations to figure out the projectile's initial vertical velocity, horizontal velocity, time spent in the air, its peak height, and finally its distance. Doing the math is a little bit of a lengthy process, so to abridge it, I found that a piñata shot out of this cannon would be traveling up and forward 1,509 meters per second. Since this is a 45-degree angle, the x and y distances are the same. It would also be in the air for 154 seconds or 2.5 minutes, would reach a max height of 116.12 kilometers, and reach a max distance of 232.4 kilometers. That may seem like a lot at first glance, but it's actually a disappointingly small range. A cannon with that much firepower would only be able to launch piñatas within a circle 42,400 square kilometers wide, or just within the confines of the state of West Virginia. To put that in perspective, if we wanted to use the same cannon but somehow get it to put out enough firepower to reach all of North America, the projectile would need to be going 2,931% faster, or about 33,665 kilometers per second. That is extremely fast, by the way. faster than the super high-altitude research project's proposed 7 kilometers per second, faster than the space shuttle, faster than Voyager 1, faster even than the fastest man-made objects ever, Helios 1 and 2, which were launched in 1974 and 1976 respectively, and reached a max speed of 70.2 kilometers per second. In fact, that speed is about 10% the speed of light. With our current technology, we just don't have the ability to accomplish these speeds, so alas, Piñata Central would just have to use the much more boring ships and airplanes method to transport piñatas to any party in North America. That is, unless they wanted an exclusive demographic of West Virginians. Thanks for watching, and as always, if you have a question you want answered, leave it in the comments. Also in the comments, tell us, is there a better, cooler way of getting piñatas to their destination besides cannons? Do you think we could eventually find a way to get a cannon to fire objects further, or even into space? Either way, I'll see you for the next mind-blowing episode of Proof of Console.